Greetings everyone. Welcome back again to SanfordFlipMath. This is, I believe, the fourth and final installment of section 1.2. We're talking about describing functions for PreCalculus. 1, 2, and 3, A, B, and C covered all of the different attributes, and this one is merely just here to give us some more examples. That is the whole purpose of this. So no new notes, just some more examples. So just a quick speedy recap. Remember domain, the set of allowed x values. Range, the set of possible y values. Asymptotes are closely related to the domain and range. They're not identical in every situation, but we're going to focus on vertical and horizontal asymptotes. Discontinuities are break. That could be a break in the graph, and what we are going to focus on is its x value and the type. So there are three types: infinite, which is an asymptote, or gap from left to right of missing x values. Point, or also called removable, or sometimes referred to as a hole in the graph. And jump, where the graph comes along just beautifully and smoothly, and then it decides, boop, it's going to pop up or down. And again, you state the locations for these by giving their x values. Increasing and decreasing is really about slope. If it's increasing going up from left to right, it is increasing in that set of x values. If it's going down like a negative slope, then it is decreasing for that set of x values. Okay? Again, read that from left to right. Extremes, maximums or minimums, sometimes called extrema, or which is plural for extreme. I know it sounds funny. Extremes would just be more common nowadays. Maxima is plural for maximums, and minima plural for minimum. Remember, an extreme is just a maximum or minimum y value. If it asks you for a max or a min, give its y value. Its location is given by the x value. Do not just list it as an ordered pair. And extremes can be either absolute, the highest or lowest for the whole graph, no y value higher, no y value lower, or it could be a relative, sometimes called a local maximum. In other words, it's a higher low point compared to those nearby. And then the last chunk is end behavior, and that's what happens on the left end. And on the right end, what y value is it approaching? And symmetry is for our purposes, either odd, even, or neither. Odd is when you have rotational symmetry around the origin, and that's when you have f of negative x. That's how you would prove it. F of negative x is equal to negative f of x. Okay, so that's not really the goal there. So that's odd, and that's for proving. And again, we're talking about a graph that looks something like that maybe. And then even, you'd use this for proving, and again, graphically, we're talking about something that looks like that. It's balanced across the y-axis. And again, not all functions have odd or even symmetry. There are things that have neither. Okay? All right, so this is what the whole list looks like. This is how your test is going to have it. And at the top, there will be some kind of an equation, and then you're just going to fill in every single one of those blanks. So you're going to say what the domain, range, vertical, all of that. Okay? All right, so let's do that. Most people feel more comfortable if they look at a graph. I got a ton of people that say, I'm a visual learner, so I need to see this thing. Okay? This is symbolic. Some of you can look at this and think to yourself, x squared is always going to be positive, because when I square it's going to be positive. And then if I do 5 minus that, they're going to, if this was 0, 5 would be the biggest number. And then they're thinking in terms of if I subtract something positive away from 5, so 0 from 5, or 1 from 5, or 4 from 5, or things like that, then every answer is going to be less than 5. And so we're talking about range. What kind of numbers can you square? Any number. Positive, negative, fractions, decimals, whatever. Okay, so again, back to visual, because I know some of you are sitting there going, what did he just say? If I just do a little quick sketch of this thing, its vertex is at 0, 5. It opens down. It's a parabola with a negative leading coefficient, because that's the coefficient for the highest exponent. It's going to open down. Okay. All right, so let's go back to domain. You can put in any kind of x value. Every single x value from left to right is included. There are no breaks, jumps, goofiness. So the domain, all real numbers. Okay. Again, if you feel more comfortable by writing something like the interval notation from negative infinity to positive infinity, That's beautiful. Love it. If you don't write this. If you write that, I'm like, what's that? So it's got to be a fancy R, a thick or double bar on the R, loopy looking, capital. It's got to be fancy. Okay. I know fancy's in the eye of the beholder. Sorry. Okay. Y values, again, the range. Okay, so this is Y values. This is X values. Okay. Range, well, the biggest Y value I see present on this, remember Y is about up or down. The biggest Y value I see is 5. What else do I see? Well, everything else down. It keeps going down forever, right? It keeps going. Okay, so one way to say that would be Y is less than or equal to, because it includes the 5. Some of you are starting to like interval notation by now. You could say, well, it starts at, the smallest value would be negative infinity, and it goes all the way up to 5. Now, this is a little goofy, and I know some of you look at this and go, I don't like that. Okay, that's fine. You need to be able to read it, and I don't expect to specify what kind of notation, but you need to be able to read it, because on multiple choice questions and things like that, it may be in interval notation. Easier to type a parentheses or a bracket than it is to find less than or equal to on the keyboard. Okay. So where are the vertical asymptotes? Vertical asymptotes typically come from where the denominator equals 0. So you should be saying to yourself, self, I don't see no denominator. So there's no denominator there. Notice that there are no breaks in this thing. It just keeps going and going. It's all connected to itself. So, and there are no horizontal either. Continuity, I'm going to pop down here. Since there are no vertical asymptotes, no breaks in the graph, then we're just going to say it is continuous. Okay. If it says discontinuities, and I think that's how it's listed on your worksheet, then you can just say none if you prefer, or if you want to write continuous, you can still do that. Okay. End behavior. Every time you write end behavior, it's going to be x approaches negative infinity, y approaches, then we need a y value there. X approaches positive infinity, y approaches, and then we need a y value there. Okay. All right, so here we are again. As x approaches negative infinity, going to the left, y is going down to negative infinity. As x approaches positive infinity, y is going down to negative infinity. So both ends down, it's an even function. Whoops, sorry, I didn't mean to give that away already. So it does the same thing on both sides, left and right. Okay. All right, maximums and minimums. Well, I see a maximum. That's a high point. Okay, now I'm going to write 0.5 here so that I know what information I have here, but remember the maximum itself is a y value. It is a max. It is also, there are no points higher than this, so it is an absolute max. This is a terrible way to write this. And it is located at x equals 0. Okay, probably should have said an absolute max of 5 at x equals 0. Okay, I like that better, but whatever. If you wrote this, we'd be fine. Okay. Okay, so it is a max. Its type is absolute, and what is it? It's 5. And where is it? At x equals 0. Okay. Intervals where increasing and decreasing. Increasing, remember, means positive slope. As you're going from left to right, it's got to be going up. Okay. Well, that's here. So that's increasing. Okay, well, where is it increasing? For what x values? Okay, so it's increasing, decreasing. It's increasing for all of the x's less than 0. Or if you want to say negative infinity to 0, you can. That's really kind of yucky the way I wrote that, sorry. Decreasing, well, that'd be over here. Okay, so to the right of 0, or from 0 to infinity. Don't include 0 itself because it's not decreasing at 0. At 0, it's actually got a slope of 0, and that requires a little bit of calculus to figure that out, but that's okay. We'll get there eventually. Okay? And then odd, even, or neither. Well, what's the exponent for the 5 term? Not the exponent for 5, the exponent for x. So this is the same thing as 5x to the 0. 0 is divisible by 2, so it is an even number. You can look that up if you don't believe me. And x squared, well, that's even also. So I'm going to go with probably even based on the exponents. That's my guess. Okay. Okay. One of the other things we said too, though, if it's even, that it will be symmetric over the y-axis. Okay. Now you got to be specific. You can't just say symmetry because odd has symmetry also. And so again, the idea here is, okay, my graph's pretty jacked up. The idea here is that this and this are mirror images of each other, and this is the mirror. Okay. So that implies, since that line is in fact the y-axis, it has to be at the y-axis. It can't be anywhere else to talk about an even function. It's at the y-axis, so that would be y. Now, so it says, symmetry, odd, even, or neither. If odd or even, state how you know. Symmetric over the y-axis, that's good enough. If it would have said prove, which might be the next question on a test, then we would go back to f of x equals 5 minus x squared, and we would do f of negative x. Everywhere you see an x, negative x. Simplify this. Well, negative x times negative x is just x squared. Well, that's what f of negative x equals. Well, guess what? That's what f of x equaled. Okay, so those are equal to each other, so therefore it's proven. Cool. All right, well, that was one example. Feel free to rewind, pause, whatever. Okay. All right, domain. Denominators cannot equal 0. So x minus 2 cannot equal 0. So x must not be able to equal 2. Now, if you type this sucker into your calculator, remember that you're going to have to put parentheses around the numerator, parentheses around the denominator, unless you're in the new system. If you're on the new system and you type this in as a fraction, so you can hit, you can type the alpha button and then the y equals button, and those top keys become soft keys, like old school cell phones had soft keys. Okay, so not a touchscreen cell phone, but and then the top row becomes soft keys when you push alpha. So you can then get some extra functions out of the deal. So now if you don't have the new system, then you can download it at home, or if I'm completely bored out of my mind, then you can come see me and we'll try and work something out. If you have a newer version of the 84, now that is just a TI-84 issue. TI-83's, sorry, I can't do it. All right, so anyway, you can type this in as a fraction if you have the new system. Okay. All right. If you type this into the calculator and then go to table, x equals 0 is going to, for a y value, it's going to say error because you can't divide by 0. 2 minus 2 would be 0, and 7 divided by 0 is undefined. Okay. All right. Since that factor does not cancel out with anything in the numerator, I'm willing to bet money it's also a vertical asymptote. And if we do a little graphing, you'll notice that it will have a vertical asymptote there. Now, I'm going to do a little cheatage here, and I know that this graph is going to look something like this. Mr. Sanford, how do you know that? All right, so let's talk about how I know that. Okay, so I know the vertical asymptote because the denominator can't be 0, and I know that this is not a factor that divides out. It's not a common factor. I can't reduce the fraction. Okay? No, you can't reduce x and x. Okay? I will say, however, that you can, thank you, look at the x term, though. Okay, the highest exponent for x is first power. So if I match those up, any horizontal asymptote should be about 3x over x, also known as 3. So I'm willing to take a peek at y equals 3, and I am guessing that y doesn't equal 3 is the range. Okay? Now watch this. When I go far, far, far to the left, as x approaches negative infinity, y approaches whatever this line is. Well, that's y equals 3. As x approaches positive infinity, y approaches whatever this line is. Hey, that's still 3. There is a very clear connection between these three. Again, it is not foolproof. If we have time to do the next example, then you'll see that. If not, you'll see it in class. So that's an issue. Okay? All right, continuity. I know there's an asymptote. So there is a vertical asymptote, which is an infinite discontinuity. Where is it? At x equals 2. So here are those connections again. Okay, again, it's not perfect, but it's pretty compelling. Okay, I'll put it that way. Okay, all right, next up, maximums and minimums. Okay, where is the spot where this graph keeps going? It goes up and then it comes back down. So I see as I'm coming along, this is going down, way down to infinity, but I don't see any spots where there's a high point or a low point. I see it's getting lower. I see it's getting lower, but it's not going back up. Okay? There are no maximums or minimums for this. You could write NA for not applicable, or you could write none, or you could fill in, if you got enough room in the box, Mr. Sanford, you can't fool me, nah, nah, nah. Okay? Increasing and decreasing is about slope. This has a negative slope. As I read this from left to right, this is going down. As I read this from left to right, this is going down. Okay? So this time, increasing and decreasing, well, it's decreasing where? Well, everywhere. Everywhere except 2. You could write it decreasing. You don't have to write this. I'm good with this. You can write this if you want. Some people feel more comfortable doing that. Okay? All right, last question. Is this function odd, even, or neither? Okay, now remember, the line that you have to look at for talking about odd, even, or neither, if you're talking about even, the line is the y-axis. Okay, so is this symmetric across the y-axis? Does this look the same on both sides of the y-axis? Nope. Okay, so even is out. Okay, odd, can you rotate it around the origin? Can you rotate this around 0, 0? Well, here's 0, 0. If I rotate this, now notice that this comes on the other side of the y-axis. If I rotate this, if I spin this 180, does it look the same? Nope. All right, so you guessed it. This bad boy is neither. Well, how do you know? Not the right kind of symmetry. This does have point symmetry. It has point symmetry at the point 2, 3. It does have rotational symmetry at 2, 3. If you spin it at 180 around there, then it does match up, but it's in the wrong spot. So wrong symmetry. Don't say no symmetry. It has the wrong symmetry. Okay. Now it does technically say if odd or even. That's the neighbors. Sorry. If odd or even, state how you know. Well, this is neither. Technically, we don't have to say why. I just want you to know. Okay. All right. I want to point out one more thing, and I know that I'm going to be cruising on this one. I'm going to do a little factoring because I'm psychic. Okay, because I made up this example, and I know that something special happens here. Okay. If you go back and type this equation into your calculator, it's going to give you a problem for x equals -1 and x equals -2, and so we're going to say x can't be those things. Having said that, also worth noting that that does cancel out, but domain comes before it's simplified, because you still can't divide 0 by 0, even though that is something that would have canceled out. Okay, so do your domain before it's simplified. Now, okay, please note that x plus 2 is in the denominator, not the numerator. So this is 1 over. Okay, so where are the vertical asymptotes? X equals -2. Okay, so this is what I'm talking about, where, you know, these things go together, but they're not perfect. There are discontinuities at x equals -1 and at x equals -2. There are discontinuities. Okay, x plus 1 is a factor that disappears, though. It is a removable discontinuity or a point discontinuity, whereas the other one is something that you just can't get rid of, and that is an infinite discontinuity. Okay, let's do a little sketch. This graph's going to look exactly like 1 over x plus 2. Little asymptote there. Any idea where the horizontal asymptote? Well, match up x squared with the x squared up here. There is no x squared, so it is 0x squared. So if I do y equals 0x squared over 1x squared, that is 0. So horizontal asymptote y equals 0. Range is probably not going to have 0 involved, but I will tell you there is another thing not involved. Okay? We'll get there in just one shake here. All right, so here's your horizontal asymptote. You don't really need to draw that one in because it's the asymptote. The asymptote is the axis, but I'm going to draw it in just to be complete. Okay? All right, so here we go. If I put a couple of points in here, quick little note here, like if I put in 0, then this is going to be 1 over 2, 1/2. Positive 1/2 is the y-intercept. And I know it doesn't cross this asymptote, so it's going to look like this and like this, and there is a but coming. But we said x can't be -1. So quick little note here that, yeah, it erased more than I wanted it to. Sorry. It's all right, I'll fix it. So at x equals -1, that's this x value. There's a hole. Oh man, I didn't want to fill that in. All right, just pretend. It's not filled in. I don't want it that big, but it is what it is. All right, so that's what the graph looks like. Now that point, we know it's x value. The question now is, what's the y value? Well, I'm so glad you asked. I can get it by putting it right into the simplified version of this. So 1 over -1 plus 2, 1 over 1 is 1. That is the other value that is forbidden from the range. Okay? All right, let's take a quick peek at M behavior. We got to fly through this. As I go way, way, way to the left. Oh, sorry. I'm going to change colors on you, because I want that stuff to go together. As we go way, way, way to the left, y approaches 0. As we go way, way, way to the right, y approaches 0. Okay. Maximums and minimums. Now, this is an interesting point, but remember, it never really gets to that 1. And so don't say 1.1 is a maximum or a minimum, or I'm not sure what, I guess it'd be a minimum. Because it could have been 1.01 or 1.00. So the point, there is no max or min for this. Okay, this is very much like the last one. There is no high point, there is no low point. It keeps going up forever, down forever. There is no point where it goes up and then comes down. This would be a max. We don't have anything like that. This would be a min. We don't have anything like that either. Okay. Increasing or decreasing? Well, sorry, it's the decreasing parade. This is decreasing. This is decreasing, not here. So this is decreasing everywhere in the domain. Well, what's that? X not equal to -1, X not equal to -2. Okay? And then, well, there are a couple, that point totally jacks up pretty much any symmetry we're going to have anyway. It's off center. The asymptote, the vertical asymptote is to the left of the y-axis. If it was on the y-axis, we might have something. This is going to be neither. And really, there's no symmetry for this. There's no line symmetry. There's no point symmetry. All right, well, that was speedy. Under 25 minutes. I'm happy about that. If you have any questions, well, we will chat again tomorrow. Feel free to rewind to anything, look back at other recordings, and we will see you in class. Happy, happy math.